So it really is kind of a multi-billion dollar viral advertising campaign for EVs. Without running any billboards, without showing any ads on TV, the Cybertruck just being there on the street just causes people to turn their head, stare at it, stop what they're doing. It would be difficult to drive around in a city. It would be challenging to navigate tight streets. But it's actually strangely just the opposite. You can actually navigate around the city more easily in a Cybertruck than you can in a Model S. The turning radius is tighter. It's easier with the steer-by-wire system. So you really have this vehicle that is larger, has tons of space, tons of utility, can tow, gains all this functionality. So we're entering a new phase of EVs. Before, people said EVs are only good for the smaller passenger cars. Well, now we're seeing electric trucks. We're seeing electric semi-trucks. Tesla's going to start production in Nevada of the Tesla Semi, and they're rumored to be starting in Berlin as well. And we're seeing, commercial vehicles, large vehicles from BYD. Pretty much every segment where there's a vehicle, there's now an electric version. And in the case of the Cybertruck and many other examples like the Tesla Semi, the electric version is often way more advanced than the gas-powered version in many ways. So we're really entering a new phase where every category is going to have electric options. Call it sort of software 1.0 versus software 2.0. This is a new paradigm of writing software. They've moved to an architecture where you just take in the images and the steering wheel and pedals outputs come out. So you take in the images to the neural net, you inference it through the neural net, and the neural net tells you how to move the wheels and the pedals. So this is a radically different approach. They removed 300,000 lines of C++ code. So I think there's going to be a moment of shock like we've never seen when they expand internationally and people see for the first time that a Tesla, even an old Tesla from October 2016, can run this software and suddenly drive itself. They made the car drive better, not by adding, but by removing. Most companies ask, what can we add to make the self-driving better? Can we add more sensors? Can we add more cameras? Can we add more lasers? And they end up creating a very costly solution. Elon Musk and his team think the opposite way. They think, what can we remove? As a matter of fact, the performance of the software has actually improved, removing the code. A lot of people said, oh, the hardware is maxed out. You need more compute power to be able to drive the car better. That ended up being wrong. It turns out that this new version drives better and it's also more compute efficient because instead of they get in the car, they push one button, it takes them all the way to their destination and parks without them doing anything. People will start to believe that yes, every single one of these cars is going to become a driverless car. All 6 million of them around the world.
Good to see you whole, Mars. It's been quite some time since our last space back in September. It's been almost half a year. How have you been?
I've been great. A lot of exciting things have been happening.
That is very true. Two important things happened in the past 6 months. FSD version 12 and Cybertruck. Personally, the most exciting thing for me is you getting a Cybertruck. So let's dive right in. The Cybertruck selling price from Tesla appears to be lower than its fair market value. Yet, it's still quite a hefty investment. What inspired you to purchase the Cybertruck? Was there a particular moment or event that influenced your decision?
Yeah, I actually attended the unveiling in 2019, and pretty much as soon as we left, I placed a reservation. So it just looked like the craziest thing, but I was just sort of drawn to it. There's something just kind of beautiful about it. It's just so out there. And so I put in a reservation right away, not 100% sure if I would go through with it. But when I saw the final product, it was not just a strange looking vehicle, but Tesla's packed so much technology in here that they've never shipped in a vehicle before. I was surprised that it's really kind of just the best Tesla. It has the 4680 structural pack. These battery cells are made right by Tesla in their Austin, Texas factory. And they take those cells, make them into a pack, and make that the floor of the car, all within one roof. So really raw materials coming in, anode and cathode being created through this really innovative new dry electrode coating process. And they make the pack, they make the vehicle right there. This is a huge leap forward for Tesla and one that they've been working towards for a long time. Then you have the steer-by-wire, the rear-wheel steering, the new air suspension. It just has more comfort than any other Tesla. And everywhere you go, people are just turning their head and looking at it and asking questions about it. So I definitely love this thing, and I hope Tesla starts shipping them around the world soon.
From what I've seen on X, the Cybertruck seems to really turn heads, with people often reacting strongly at the sight of it. How's your experience been in this regard? What kinds of reactions do you usually get from people when they see your Cybertruck on the road or when you've parked it?
Yeah, it's really been a pretty positive experience overall. I haven't really seen any negative reactions. So it really is kind of a multi-billion-dollar viral advertising campaign for EVs. Without running any billboards, without showing any ads on TV, the Cybertruck just being there on the street just causes people to turn their head, stare at it, stop what they're doing. You see other cars on the road, they're trying to make a turn, you pause to let them go, they just stop, they're frozen. They're looking at the Cybertruck. And people come up to you everywhere you go, every time you park it, they ask you, "What is that thing? Is that the new Tesla truck? What do you think about it?" Kids come up to you, they go, "Wow." They're staring at the thing. It's like no other product I've ever seen before. I've never seen any product that I can remember that just draws people towards it so magnetically. And maybe that'll change as the product becomes more common. Tesla doesn't intend for this to be a niche thing. They intend to mass produce these, and they intend to produce, I think millions of them ultimately. So if they succeed in that and they can get the cost down, these things will be everywhere. And maybe people will sort of get used to them. But right now, when most people haven't seen one, it's definitely a crazy experience driving around in one. It definitely turns heads everywhere it goes.
How satisfied are you with your Cybertruck so far? Could you share with us some of the highlights and any challenges you've encountered with it?
Well, I think it's definitely exceeded my expectations. I'm surprised at how easy it is to manage. Here in San Francisco, we've got really tight streets. We've got a lot of really challenging situations. And you would think that such a large vehicle, it's larger than any other Tesla that the company's ever made, it would be difficult to drive around in a city. It would be challenging to navigate tight streets. But it's actually strangely just the opposite. You can actually navigate around the city more easily in a Cybertruck than you can in a Model S. The turning radius is tighter, it's easier with the steer by wire system. So you really have this vehicle that is larger, has tons of space, tons of utility, can tow, gains all this functionality, but it still has the heart and soul of a Tesla. It accelerates like a Tesla. You can still navigate through tight spaces. The front camera makes it really easy as well to do that. And you gain a lot of functionality without missing too much about having a smaller car. It's got the utility of a truck, but it drives like a sports car. It really is true what they say. And it's really fast, just like any other Tesla. And I've got the slow version, and I can't even believe how fast it is. So it definitely blew me away. I thought, I'm not really a truck person. I wouldn't really drive the Cybertruck day to day. But then when you try it, you realize, I could actually see myself driving this day to day. It's not just for truck drivers. Truck drivers are definitely going to love it because it's a truck that's a Tesla. But I think a lot of other people will just appreciate the space, the comfort, the features it offers that no other Tesla has yet. For example, the power outlets in the back and in the cabin where you can just plug in anything. I can plug in a Starlink in the bed and I can connect to the internet anywhere. I can plug in a microwave or a rice cooker or a stove, any electrical appliance, and I can just use it anywhere. So I can even use the battery to power my home as a home backup. And this Foundation series came with a free wall connector that allows me to do that. So the same cable I use to plug in and charge my Tesla at night, it'll now be able to go the other way and take power out of the battery and power the house in a power outage. So it's a really incredible vehicle that has features that no other Tesla has yet. And that surprised me. Originally, I thought, it's not really for me. I'm not a truck driver. But now after seeing it, it's kind of hard to imagine giving these features up.
Thanks for sharing those insights. On the flip side, have you encountered any challenges along the way? We'd love to hear about any obstacles you've faced.
Well, it is a bigger vehicle. So, for example, parking it on the street in San Francisco is more challenging in a situation where you need to do things like that. Obviously, it is a bigger vehicle. They can't bend the laws of physics. So, depending on your situation, you may want a smaller car or a larger car, depending on your needs. But overall, I mean, I don't have a lot of complaints. I'm just trying to think about anything. Well, there's no autopilot yet. It has cruise control and you can see the visualization, but there's no autopilot or FSD. So that's coming in a future update. When that comes, I think it's just going to make the product even more incredible. Like that is just going to be the most killer road trip machine. It already is, but you're limited to cruise control. You have to manage steering yourself. So that would probably be my biggest challenge about the Cybertruck is I'm so used to full self-driving now that going back to a car that doesn't have it, even if it is temporary, is a huge pain. I find myself forgetting to take freeway exits, forgetting to take turns because I'm so used to the Tesla just doing it for me.
Would you recommend the Cybertruck to friends or family? In your opinion, who stands to benefit the most from owning a Cybertruck?
Yeah, I think that pretty much anybody should consider a Cybertruck if they live in the US and they can get one. Maybe not at this price. Maybe wait for the $80,000 or $60,000 version to come out. With the point of sale credit, the $60,000 version should come in at 53,000, which is well below the 60,000 average selling price for a truck. So it actually is going to be pretty affordable. So if you really want a large, comfortable vehicle, great for taking long trips and everybody's comfortable, the safest vehicle for you and your family, the most advanced technology, then definitely look at a Cybertruck. But if you need a vehicle that's not so big, then you can take a look at one of the sexy vehicles, Model S, 3, X, or Y.
Is there anything else about the Cybertruck you'd like to share with us?
Yeah, I just think it's a great vehicle for taking adventures. It's so much less fragile than other Teslas. You're not going to worry about this thing getting rock chips if you're out on the highway. You're not going to worry about a shopping cart hitting your car and scratching the paint. You're not going to worry about taking it through some water or taking it camping, taking it off road, really challenging it. And so these are things that electric vehicles haven't been that great for before. But that's changing now. Now you've got the Cybertruck, you've got the Rivian, you've even got electric trucks from Ford and GM. So we're entering a new phase of EVs. Before people said EVs are only good for the smaller passenger cars. Well, now we're seeing electric trucks. We're seeing electric semi trucks. Tesla's going to start production in Nevada of the Tesla Semi, and they're rumored to be starting in Berlin as well. And we're seeing, commercial vehicles, large vehicles from BYD. Pretty much every segment where there's a vehicle, there's now an electric version. And in the case of the Cybertruck and many other examples like the Tesla Semi, the electric version is often way more advanced than the gas powered version in many ways. So we're really entering a new phase where every category is going to have electric options. In the past, if you needed a truck, it was going to be a gas truck. That was the only option. Now there's another option for people who need to buy a truck. So it's a really powerful moment, and I think it's going to change the way that people look at EVs.
Now, let's talk about exciting developments in FSD. We already covered a good amount of the evolution of FSD in our last space, but with the introduction of the end-to-end version, FSD version 12, it's important to compare it with previous versions. What are the most significant differences with the end-to-end version of FSD?
This is almost like FSD Beta 1. It's almost like what they should have started with. So, over time, the software has been eaten more and more by neural nets. We call it sort of software 1.0 versus software 2.0. This is a new paradigm of writing software. So, in software 1.0, this is what you think of traditionally as software. You have humans writing code, and they test the code, they have some mistakes in their code, so they fix the code, and then once the code is working, they ship it. That's the traditional way we've had since, the dawn of computers. Now, software 2.0, this new way, is an approach that's much more powerful in some ways. Instead of writing the algorithms ourselves, we allow the computer to discover the algorithm on its own. And we show it the data and we tell it to sort of map out those relationships, and it can do a much more rich job than we ever can. So originally, everything was in C++. Then over time, more of the stack was eaten by neural nets and deep learning. The perception stack became deep learning. They would detect cars and things like that using computer vision, and they would drive using that. But the perception system would kind of say, okay, here's a bounding box where there's a car, here's a bounding box where there's a car, and then you would still have C++ code. So it was very challenging to write that code that drove the car. And over time, the neural networks came to eat more of the stack. They ate some of the perception, and the planning and control was still in C++. Now, with version 12, they've moved to an architecture where you just take in the images and the steering wheel and pedals outputs come out. So you take in the images to the neural net, you inference it through the neural net, and the neural net tells you how to move the wheels and the pedals. So this is a radically different approach. They removed 300,000 lines of C++ code. And it turned out their entire approach was kind of stupid in a way. Instead of saying, okay, we need to detect stop signs and then detect all stop signs and find examples of stop signs in different scenarios, stop signs that are partially blocked, and then program it to say stop at a stop sign. If we just tell it to predict the steering wheel and pedal outputs for any input, we have all this perfectly labeled data. We can learn from just real humans driving. And here's the thing, we don't need to program in all of these rules. We don't need to tell it how to drive. It'll actually just discover itself by watching humans. And what's more, the methods that it learns are much smoother than anything we could come up with ourselves. And now there's no room for bugs essentially because there's no code, if you understand what I mean. Because it's coming from training rather than code, you don't have to worry about errors in the code. The code is very minimal for the training and inference process compared to what they had before. So this is a paradigm shift. It's basically like they're starting over, and the results are dramatic. Every version of FSD for the last 3 years has always been robotic, just made bizarre choices that just seem to make no sense. It could be very impressive at times. It could complete drives without any intervention. But the fact is, it shouldn't be amazing that it can do that. It should be normal. And that's really what FSD Beta 12 feels like. If I had to sum it up in one word, it's comfort. This thing is just so much more comfortable and human like than the old approach. It's not 100% solved yet. You still need to monitor it. You still need to be able to take over at times. But it's really capable of driving you from curb to curb without you touching a thing. And it can run in any Tesla around the world. So they're just getting started with this new approach. This is the first release of this new approach. I think it's going to be extremely promising. I think it's going to be the start of a much faster pace of improvements and a much higher level of comfort and a much higher level of performance where more and more drives are completed without the human having to intervene or do anything at all. And I think that as this gets around the world, that's also one of the really important things about FSD 12. With those 300,000 lines of code that taught the car how to drive, it would have been a lot of work to port it to Europe, port it to Australia, port it to South Korea, port it to China, and try and have this C++ code, if there's any programmers here, they know what a nightmare this would be. That handles all the different kinds of roads and situations and signs all over the world. It would be a nightmare. That's why Tesla has kept it really to North America for now, just because it would be such a headache to support all these different countries. But with V12, a great chunk of that code is eliminated. It's now just picking up the rules just by watching. And so this architecture, I think, is going to be a lot easier to scale to other markets, to be able to bring to Europe, to be able to bring to China, Australia, New Zealand, South Korea. Hopefully soon, within the coming years, every country that Tesla sells in, they should also be able to sell full self-driving. It really is, to me, an integral part of a Tesla. Like, I question, is it even a Tesla if it doesn't have full self-driving? Even though most of the world, 66% of Tesla's customers, can't get it yet. So I think there's going to be a moment of shock like we've never seen when they expand internationally and people see for the first time that a Tesla, even an old Tesla from October 2016, can run this software and suddenly drive itself. And I was shocked the first time I tried FSD beta 3 years ago, and the software was much worse at driving compared to how it is now. It made much more erratic maneuvers. It was much scarier. And now it's so smooth. When international customers in Europe and Asia and other markets try FSD Beta 12 for the first time after being on, the 5-year-old basic autopilot, they're going to be shocked at how in just a 30-minute software update, everything changes and the car can just suddenly navigate through cities, suburban areas, rural areas, just like a human.
With the shift to version 12, it seems Tesla is now emphasizing data training over manual code corrections and rule creation for FSD updates. This marks a significant change in the underlying process, even if it appears as just another version update to end users. How do you view the impact of this approach on future updates? Do you anticipate more frequent updates with substantial improvements becoming visible to users?
Yeah, I do expect it to improve faster. You're not limited now necessarily by the bandwidth of engineers to think about a problem and to make a change in the code that improves the situation they're addressing without making anything else worse. That's a very challenging thing to do for a human engineer. And as a matter of fact, self driving is just so complex that it may be practically impossible for a human engineer to handwrite a solution. Clearly, it is theoretically possible if a neural net can do it. But just like we don't have human written algorithms that can understand speech, translate speech, do text to speech and speech to text, things like that, they're all done with deep learning because it's kind of just beyond our comprehension to even conceive of how to construct these algorithms. But if you just show it a lot of data, you show, for example, the same text in English and Korean, a neural network can learn how to translate between them. And I think it's kind of the same in self-driving as well. The real world and all the variation between it is just far too complex for a human engineer to sort of encapsulate well. Only an end-to-end approach, I think, can really work. And I think that's pretty clear to everybody who's used it. So learning the code, looking at all the data, finding a solution that works, keeping everything, millions of scenarios in mind. That's really what the training process does, as opposed to sort of the human engineer. So it's a lot more brittle. Things can get fixed now without the engineer even being aware of the problem. Just the nature of someone disengaging, a video being sent of that scene being driven through correctly, and training again can fix issues that weren't even on the engineer's minds. And they noted that behaviors like U-turns and pulling over weren't actually programmed in, they just appeared. So it's a tremendous leap to remove this constraint of having to have an engineer involved in designing and debugging and rolling out a feature. It obviously presents new challenges. You need a lot of data, a lot of storage, you need a lot of training compute, but I think the results sort of speak for themselves. So I think only end-to-end neural networks can produce true self-driving that can exceed a human. Human written code is just too brittle and fragile to be able to adapt to all the variation in the real world.
Considering the capabilities of the current FSD version 12.3, how would you rate its safety in comparison to that of a human driver? Could you express FSD's performance in terms of a percentage? For instance, does it match 70% or 80% of a human driver's ability?
It's difficult to make a direct comparison with a human because it has different strengths and weaknesses. On one hand, it's more vigilant and observant than even the best pro driver. When a motorcycle approaches FSD from behind, it moves over to give the motorcycle extra room, often before you've even seen the motorcycle. So the car's moving over, you're thinking, why is it doing that? Then you see the motorcycle pass by. So because it has cameras all around, it's looking, it never gets distracted. It has capabilities that even the best driver doesn't have. Yet at the same time, it lacks the common sense of even a child. So it's a very different thing than a human. It doesn't drive quite like a human, but it's getting much, much smarter. It is getting increasingly rare to have to take over for safety critical issues or other issues. The other day, I had a day where all the drives were just done perfectly. There was no input required from me. So I think that's going to happen more and more often. It's still far from good enough to be able to drive without a driver, but it's improving so rapidly that we really are looking at a situation where you probably want to talk about the number of months this is going to take rather than the number of years. Maybe 18 months, maybe 24 months, but progress is just happening incredibly quickly. And the rate of AI training compute that's being added, the rate of advancement across the industry, the new things that are being discovered about how to build better machine learning systems, the amount of capital, the amount of money being put into AI right now, it's incredible. We're really seeing a takeoff here that I think is going to change almost every aspect of our lives. And the fact that our cars drive themselves will be just one of them.
In the FSD videos you've shared, we've seen moments where FSD version 12.3 operates perfectly. Yet, there are instances where it seems to falter more than expected. What do you think contributes to this inconsistency in performance? Have you noticed an increase in the variability of FSD's performance since the update to version 12.3? If so, any thoughts on why this might be happening?
Well, I'd say in general, the software works much better, more consistently. Most of the drives are zero takeover, and a lot of them don't require any input at all, no accelerator press or anything like that. But depending on what happens during the drive, you may or may not encounter some issues. For example, in one of my drives, there were a lot of flashing red traffic lights. This current build can't handle flashing red traffic lights properly. Here in the US, when the traffic lights are flashing red, you're supposed to treat it as a four-way stop. But the system seems to get confused and stop and go every time the light blinks. So, in one drive, we had many red flashing traffic lights. That required a lot of accelerator presses to get through them. Whereas if I had another drive, a normal drive, without these red flashing traffic lights, then I wouldn't have any intervention required. So essentially, they have a list of situations, probably a list that's a million items long of different situations that can cause problems for the software. And what they now need to do is they need to find examples of people handling those situations correctly, gather the data, train on it, release a new model, and that should hopefully improve that. And they need to go down and down that list of issues until all of those problems are solved. And then it should be able to drive more safely than a human. There may be other discoveries, architectural changes along the way, things that we haven't thought of yet. But that's the beautiful thing about software. When the software is updatable, you can think of a better design and you can just ship it. You're not stuck with the same bad design forever. The FSD series originally and the architecture was something that would have been very challenging to take to driverless, but they were able to just come up with a new architecture that's better and replace it with just a simple software update. So there may be more of that. There may be more things we didn't see, more things we didn't think of, but we can send it out to the car. And what's amazing is they made the car drive better, not by adding, but by removing. Most companies ask, what can we add to make the self-driving better? Can we add more sensors? Can we add more cameras? Can we add more lasers? And they end up creating a very costly solution. Elon Musk and his team think the opposite way. They think, what can we remove? They remove the radar, they remove the ultrasonic sensors. They said the vision system should be good enough, that we don't need those things. And then they tried to make it so. And I think they're succeeding. They said, okay, we can remove these 300,000 lines of code and not have to worry about them. And the performance of the software actually improved. Removing all of that code that they had spent years writing, just getting rid of it, it made the software actually improve. And it's now able to learn things in a way that I think is going to lead to a much faster rate of improvement. So it's amazing how they can take away and it comes out better. As a matter of fact, the performance of the software has actually improved, removing the code. A lot of people said, oh, the hardware is maxed out. You need more compute power to be able to drive the car better. That ended up being wrong. It turns out that this new version drives better and it's also more compute efficient because instead of having to go back and forth between the CPU and the GPU and the neural net accelerator, everything from perception to planning and control is all just done in inference time on the inference chip that Samsung is fabricating for Tesla. So it's amazing how, again, less is more. You take away 300,000 lines of code and you get a better solution that's simpler, that's faster, that's more performant, that uses less resources on the car, but is also much more human-like than the old system. I find that to be one of the really amazing things about software, how we can come up with a better architecture that just does more with less.
I really appreciated that answer. The best part is no part. Is there any other aspect of the FSD technology or your experiences with it that you'd like to share with us?
It's a life changing experience to have a car where you get in the car, You tell it where you want to go, or actually, sometimes it figures out where you want to go itself. You push one button and it takes you there, from your house all the way into the parking lot and parks. And you get out. You don't have to do any driving. You have to monitor it today, of course, make sure it doesn't make any mistakes. But in the future, as it gets more reliable, you won't even have to do that. So, to be able to taste what the transportation experience of the future looks like, it's very nice. I think people are going to enjoy it a lot, and it's going to change the auto industry. It's going to change the energy industry. The world will look very different from today, much like the world after the smartphone is hard to recognize compared to the pre-smartphone era. And there'll be some good and bad changes, but it's just a really nice experience. It's something you can have today in the United States, you can use. I recommend people come try it if they get a chance. And it just makes being in a traffic jam, traveling long distances, just extremely comfortable even today. And it's only going to get better from here. The team has said that this is just the start of a wave of new architectural improvements they're introducing. So this isn't the end, this is just the beginning. And I think it's going to be a very exciting year. Lastly, we found out from Ashok, the head of autopilot software, that they're getting ready to ship actually smart summon and auto park. The auto park feature will be able to park using just computer vision, parallel or perpendicular. And the summon feature will allow the car to come to you without a driver in a parking lot and pick you up. So if you're within a short distance, you can see the car, you push a button on your phone, the car will pull out of its parking spot and it'll come drive to you and you can get inside. Now, they've had this feature for a number of years, but the AI powering it was very primitive. It was before they came up with FSD beta. So, this new architecture for Summon based on FSD version 12, it's actually going to work. So, this is going to be just an incredible experience for people to see their car driving around without a driver with this software for the first time. I think it's going to be a very powerful experience. I think it's going to become a lot easier for people to imagine their car becoming driverless when they can push a button and it pulls out of the parking spot driverlessly and comes to them. They get in the car, they push one button, it takes them all the way to their destination and parks without them doing anything. People will start to believe that, yes, every single one of these cars is going to become a driverless car, all 6 million of them around the world. And many people doubted it for a long time, but it's going to be increasingly hard to doubt it with these next few waves of software updates that are coming out under version 12.
Could you share your perspective on Tesla's advancements in AI computing capabilities, especially with the development of Dojo? How do you see Dojo impacting the future of Tesla's autonomous technologies?
Under this new paradigm, the constraint is no longer engineers trying to write code. You don't need more engineering talent. You actually just need more compute and more data. So, a small team of engineers can sort of manage the surface of the code. The really important thing is just to scale compute to insane levels. The more compute you have, the faster you can train models, the faster you can run different experiments, try different methods, try different variations in the data set, run different evaluations. So it's incredibly important. And Tesla's buying everything they can from NVIDIA. They're buying their DGX H100s, but they've also got their Dojo supercomputer that they have now put into production. And it's now running in Palo Alto for the same time, for the first time, and training models. But it's just the Dojo version 1. There's a Dojo 1.5, a Dojo 2 they're working on, and they have Pete Bannon in charge of the project. Pete Bannon was the chip architect at PA Semi, which Apple bought to make their Apple Silicon architecture. So this guy has designed some of the best chips in the world. And the Dojo's not just a chip, but an entire system. It's a very interesting architecture. They essentially have 25 SoCs, 25 systems on a chip that are on one wafer. And so they have very high bandwidth between the chips, which is useful when you have a large video training set and you can sort of co-locate different nodes that are processing the same data. You have a very high bandwidth interconnect between the different nodes in the system so they can all communicate with each other very fast, faster than anything else on the market. And you really have a custom networking protocol even that Tesla's developed. They call it the Tesla Transport Protocol. And the chip itself is a CPU, a very simplified CPU that just stripped out everything except what's needed. They don't even have, for example, virtual memory on this CPU. a lot of things that you would expect in any other CPU. And it's just designed to do the training task as quickly and efficiently as possible. So it's a very innovative system, not just a chip, but everything from the chip up to the system itself. And it's designed to be a fraction of the cost and a fraction of the energy usage of NVIDIA. So far, Tesla hasn't been all too successful in replacing their NVIDIA workload. I think the NVIDIA is still the main training cluster being used for the models that go into the car. But this has become so important to the success of the company that they're going to continue to invest in trying to make Dojo the best AI training system in the world. Because if they have a competitive advantage, NVIDIA has 76% profit margins. So that means if you could just make it yourself, you could buy 4 times as much training compute for the same amount of dollars. That could give you a serious competitive advantage over everybody else. So that's why Tesla continues to push on this. And, NVIDIA is a moving target. They're not standing still either. They keep putting out new chips. Tesla may have a Dojo 2 that's better than the H100, but then NVIDIA comes out with something even better. So it's a very challenging thing they're trying to do, but they're doing some very interesting work. And if they succeed, it could not only give them a durable competitive advantage, but they could actually start to sell the service to other companies like XAI and other companies that want to train a model, but would love to pay a fraction of the cost to do it.
Thank you so much for participating in our second space. It's always a pleasure to engage in conversation with you and share your views and perspectives on various Tesla-related topics. We are hopeful to see an increase in Cybertruck production and further advancements in FSD technology on our roads soon. Once again, thank you for joining us today.
Yeah, thanks so much. Always love talking with you guys. It's great to see so many Tesla fans in Korea, and I can't wait until you guys can try FSD Beta 12 on your cars too. I think you're just going to be blown away when you see what your Teslas are really capable of.
That is so true. We have some Koreans who went to the United States and tried FSD, and their minds were certainly blown away. Thank you so much for your time and perspective. Have a great day.